Hey guys, so another video because I'm out. Remember, all your phones should be in your backpack, not your pocket. And remember, because I'm not there, you are not allowed to scan and submit during class. You have to do that outside of the classroom. Okay, we're going to go ahead and get started. Hopefully no one will interrupt me during this one. We will see. So today we're talking about perpendicular and angle bisectors. We've been talking about perpendicular a lot. So a perpendicular bisector is a line, a segment, or a ray that passes through the midpoint and is perpendicular to the side of a triangle. Remember, perpendicular means they form a right angle. So this is an example of two perpendicular lines. I'm going to use the R abbreviation here. So these are perpendicular lines. If this is a right angle, this is a right angle, this is a right angle, and this is a right angle. It actually creates four right angles when two lines intersect. Every triangle has three sides, so every triangle has three perpendicular bisectors. So this line that goes through point H, if we say that this distance is congruent to this distance, or this length is the same as this length, now, and because this line is perpendicular to side DE, now we can say it's a perpendicular bisector. And that's going to mean that this angle is also a right angle. This is the same triangle, they just turned it around. Now, this perpendicular bisector, that means that this side is congruent, this length is congruent to this length, because a perpendicular bisector has to go through the midpoint that makes H the midpoint of side DE, and it happens to go through this vertex. It does not have to go through this vertex, but we know that this is a perpendicular bisector because it goes to the midpoint and it's perpendicular to that side. Remember, both those would be right angles. So it's important to remember, perpendicular bisectors do not necessarily go through the vertex. That's important to remember because we are going to learn about a particular term where it will have to go through the vertex. So you need to make sure you write down perpendicular bisector does not necessarily go through a vertex. Alright, so for finding the measure of each thing that they ask for, in this case it's side FE, they give us some given information. This line FH, that is a perpendicular bisector. It crosses through the midpoint of side DE of this triangle DFE. We know it's a midpoint because they marked it congruent, and they show us that when it intersects here, it creates a right angle. Remember, that's going to make two right angles because these are supplementary. If this is 90, then this has to be 90. They have to equal 180. Okay. So I need to prove that FE, this triangle, or state actually, what is the length of FE? I've got to find the length of FE. I don't have any other measures to go by except for this 8. I know that DF measures 8, so I need to know what FE measures. Well, if I could prove that these were congruent triangles, then I could use congruent parts of congruent triangles are congruent, and then I could say, maybe say that FE is congruent to 8, because that is literally the only number on the diagram. So as I'm looking here, I know because this perpendicular bisector creates two congruent segments. They share FH. They're both right angles. This is not the hypotenuse leg because we have not stated that we don't know what the measure of the hypotenuse is in the other triangle, rather. So we could say by side angle side, that this triangle is congruent to this triangle. FDH is congruent to FEH. So I'm going to say triangle FDH is congruent to triangle FEH. And that's by side angle side. And if that's the case, now if these triangles are congruent, that means that FD is congruent to FE. So now we know that FE measures 8. Number 2, example 2. WC is a perpendicular bisector. It bisects this side and creates a perpendicular or a right angle. So remember, both of these are going to be right angles. So we're probably thinking that we're going to find BA. BA is the length of this side. BA is the length of this whole side. Well, we know this is 15, and if this side, if these two segments are congruent, now we know that this is 15 times 2, so that's 30. Right? All they asked us to find was BA, so I don't have to get any crazier than that. If this segment is congruent to this segment, and this segment is 15, 15 times 2 gives us a length of 30. Why do I have so many boxes there? Oh, I don't even need that. I don't even need to know that they're congruent. I already know they're congruent there. All right. We are trying to find XW. XW is this length. We have an algebraic expression for this length, but we don't know how long it is. This is asking us for the length, not just for this expression. So I know that XW is 3x minus 5. I know that XY is 2x plus x. I need to be able to write an equation relating them somehow. If I knew that the triangles were congruent, or could prove that the triangles were congruent, then I could set them equal to one another and solve for x, and then I could plug in and find the length of x. So let's see, can we prove it? Well, we know this side is shared. They've marked this side because XZ is a perpendicular bisector. It has bisected this side WY and created two congruent segments. They WZ, YZ, two corresponding parts of these triangles if they're congruent. We know that this is a right triangle because this is. So now we have side, angle, side, side, angle, side that are congruent. So because these triangles are congruent by side, angle, side, now we can say that their corresponding parts are congruent. So if we say that triangle XWZ is congruent to triangle XYZ, now we can say that WX right here, or XW, is congruent to XY. So now I can set them equal to one another and solve. So 3x minus 5, these represent their length. So if their triangles are congruent, this corresponding side is congruent, and so their lengths are equal. 2x, x minus 5 equals 6. I'm going to add 5 to both sides. So now I know that x equals 11, but that's not my answer, right? I want to know how long is XW. Well, XW's length is 3x minus 5. So I'm going to replace the x with 11. 3 times 11 minus 5. 33 minus 5 is 28. So the XW measures 28. All right, the angle bisector. So if a point on the bisector of an angle, so this ray BF here, it's bisecting this angle DBE. We know that it's bisecting because the two angles that are created by the ray are congruent. They've marked them congruent here. So that makes this an angle bisector. We've learned about angle bisectors. But what this says is if any point on this angle bisector is going to be equal distant from this side or from this side. So this point will have the same length from here to here. This point would have the same length from here to here. You may not know what it is, but it would be the same. This is the converse theorem. It says if we have points that are equal distant from the sides, now we know that the angles are congruent because they have to be on an angle bisector. So if I'm given that point F is an equal distance from point side D and side E. And if I'm given it, it's got to be a perpendicular bisector here, though, right? It's got to be the same length and a right angle. So it's got to be the same length and a right angle. Same thing here. Same length, but we've got to show it that distance is measured at a right angle, right? So this is a perpendicular bisector from this side of the angle. This has to be a perpendicular bisector, this as well. So if F is the same length from both sides, now we know that ray BF is an angle bisector, and that means that these angles have to be congruent. It's a little bit fuzzier, I think. Okay, so let's do some examples and see if that helps clarify a little bit. So we're looking at this angle DHE, and there's a ray splitting this into two angles. They tell us that this angle measures 21 and this angle measures 21. Right? So now we know that this is congruent. Right? If this isn't, then that's going to make this an angle bisector. Right? If these are congruent, that makes HF an angle bisector. So HF is the angle bisector, so that's going to mean that point F has to be the same distance from this side of the angle perpendicularly as it is from this side. So if this is 7, these are congruent, then this has to be 7 as well. So because angle DHF is congruent to angle EHF, or their measures are equal, so there should be the measure here, the measure here. Now we know that segment DE is equal to segment EF. So now we know that FE measures 7. Okay. Example 5. So here they tell us that these distances from point W to either side of this triangle at a right angle are the same, so they're congruent. So now we know that W is on a bisector of this angle, an angle bisector. So that means that this angle and this angle have to be congruent now. So because AW is equal to BW, now we know that the measure of angle ACW has to be equal to the measure of angle BCW. And if those angles measures are the same, then now we know that the measure of angle ACW is 28. All right. Now let's see what we've got. We need to find the measure of angle DHE. DHE. Okay. So I see two measures that are the same here. So from point F on ray HF, I see when you measure it perpendicularly, so this length perpendicularly to this side, the length perpendicularly to this side measures 10. That makes since they're the same, they're congruent, that makes HF an angle bisector. If HF is an angle bisector, now that means that it's bisecting the angle, it's creating two congruent angles. Okay? It's creating two congruent angles. Now I can use that relationship to write an equation and solve for x. So what we're saying is, as a recap so you can write something down, because DF equals EF, then the measure of angle DHF is equal to the measure of angle EHF. So now I can write an equation. 5x plus 9 equals 7x minus 1. To get my x's together, I'm subtracting 5x from both sides. So 9 equals 2x minus 1. I'm adding 1 to both sides, so 10 equals 2x. Is this right here? Okay. And then if I divide both sides by 2, now I know that x equals 5. I want to know the measure of angle DHE. DHE. So I can plug into either of these expressions and then multiply by 2. Let's see. What is this right here? Okay, that's what they're doing. Alright, so let's see what it says. So the measure of angle DHE equals DHE equals, oh yeah, so they added them together. So together, 5x plus, I don't like that, don't write that down. We're gonna do it this way. Alright, so we know that half of this angle, so this angle DHE is this whole thing. So this angle plus this angle equals the measure of angle DHE. So the measure of angle DHE equals this times 2 or this times 2. So we're going to do the smaller. 7 times 5 minus 1. And that's all times 2. That looks a little confusing. Let's erase that. Let's say 7 times 5 minus 1 equals 35 minus 1. That's 34. So we know that these two are congruent. So now we know that the measure of angle DHE equals 34 times 2, or 68. We could have used this expression. We could have said 5 times 5 plus 9. 25 plus 9 also equals 34. So we could have used either one. So the measure of angle DHE is 68. All right. And 2 down. Have a great rest of your day.